So let's see. Let's see. Maybe we will do just one more, and then we'll move on to the next topic. Okay. So what question we can do now? Maybe something with the vector quantity, I guess. So let's see. Maybe this time not Dr. Kaku, maybe Dr. Kavat. Dr. Kavat, drives, I guess, drives to home 22 kilometer north, I guess, and then and 47 kilometer maybe southeast at maybe 60 degree. Okay, so find his displacement. Different way to find displacement. Find displacement. Alright, so last time what we had our position function. We need to put the time into the position function, take the difference. That was our displacement. But this time, what are we going to do? We're going to try to understand this problem, and we're going to find the displacement differently. How differently? Let's see. Let's get our direction correct. This is north, this is south, this is west, and this is east. Okay? So it says that Dr. Kabat is driving 22 kilometer north. Okay? So he was driving 22 kilometer to the north. So say D1. D1 is a vector quantity. Now you're going to get the idea what is vector quantity is. 22 kilometer. Okay? 22 kilometer. Then he turns around and drives 47 kilometer southeast. So southeast, he drives 47 kilometer, and the degree is 60 degrees, right? So we're going to find the 47 kilometer. Okay, so we're going to find his displacement. We're going to find something like this. Displacement from here to here. Okay, so the magnitude of the white line, that would be the displacement of Dr. Kavat. Let's see. Step one is, okay, so we forgot something. We should have put D2 equal to 47 kilometer. Okay, so now D1 is so D1 is also a vector quantity, and it has a x and y direction. So we can write D1 is equal to D1 x, and then this is this direction he was going. So here is everything is 90 degree. So x cosine is 90 degree. All right. So D1 is D1x. So D1y is D1y sine 90 degree. All right. So D1x is 22, and cosine 90 degree is, let's see, what is it? Right, so this is 30 degree, this is 45, this is 60, and this is 90. So here cosine is 1, sine is 0. Here cosine is 0, sine is 1. So cosine 90 degree is 0, so it's 0. Toward x is 0, and it is obvious. There is no x direction, x component here. This is just y component. And dy is 22 kilometer, and this is 1. So we're going to put 1 and 22 kilometer. So he was going exactly on the straight 90 degrees, so that's why he had only y component, no x component. Let's use the different color for finding d2. So d2 is d2x is d2x cosine what degree this time? It says 60 degree. All right, so 60 degree. This time he was not moving straight. He was moving toward the. He was moving. You see, he was moving toward east and south direction. Okay. So now we have to keep that in mind. We have to write 60. I guess 60 degree. I'm not sure I'm making a mistake or not. 60 degree. So 47. Okay, 47 kilometer and 60 degree. Let's try to find what is 60 degree. This is 30 degree. This is 45 and this is 60. So 2, 2, 2, 2, 2, 2. This is 1. This is 2. This is 3. This is 1. This is 2. This is 3. Square root. Okay. So that's what we want. So the cosine 60 degree is actually 0.50. All right. So let's see what is that. So 47 times cosine 60 degree is 23.5. All right. So now d2y is d2y cosine, right? Sine 60 degree is 47 kilometer times, this is square root of 3 over 2, so 47 times sine 60 degree, which is 40, square root of 3 over 2, which is 40.70. But we have to make sure that we put a negative sign here. Why are we going to put a negative sign here? Because it's going down. We say, what do we go up? It is positive. When we go down, it is negative. So since we're going down, that's why this is negative. All right. So step 3, we're almost there. Step 3 is simply dx, d1x, and d2x. d1x plus d2x is 0 plus 23.5, which is 23.5 kilometer. And d1y plus d2y is, d1y is, what? d1y is, make mistake, d1x is 0, d2x is 23, okay, that's good. d1y is 22, and d2y is minus 40.7, which is minus 22, which is negative 18.7 kilometer. So what was the displacement? So now displacement is, we almost there. In fact, this is the last step. dx square plus d, well, okay, so here is dx, here is dy, all right, so dx is dy square, okay, so now what is dx? 23.5 kilometer squared plus minus 18.7 kilometer square. So let's see, 23.5 square times 18.5 square, square root of that gives us All right, so it gives us 434 kilometer. So his displacement was 434 kilometer. All right, so he was that's how far his home was, I guess.